Algebra 1, Lesson 21. Part A is called Product Rule for Exponents, and you hopefully remember product indicates that we're talking about multiplying. And so, let's just review what exponents are first. 3 to the second power means we're using 3 as a factor 2 times. That means we're writing 3 2 times and multiplying. So that would be 9. 3 to the fourth power means 3 is used as a factor 4 times. So you'd be writing it 4 times and then multiplying. So here's 9 and here's 9, so that would equal 81. Therefore, 3 to the second power times 3 to the fourth power means, okay, we have 3 used as a factor. I was thinking 2 times and I wrote it 2. 3 uses a factor 2 times, 3 times 3, times 4 more of them. 1, 2, 3, 4. So that means 1, 2, 3, 4, 5, 6. 3 is used as a factor 6 times. So that's 3 to the sixth power. And see what happened? Those exponents, if we just add them, that simplifies it as 3 to the sixth power, because there are 2 and 4 more. So the rule, if m and n are real numbers and x isn't 0, then when you're multiplying and see they have the same base, we add the exponents. Okay, so that's what we're filling in here. When we multiply exponentials, that just means they have an exponent whose bases are the same. Remember, bases are the bottom ones. We add the exponents. Okay, when you're multiplying, you add the exponents. And just the definition, x to the first power is just x. That's an understood 1 right there. Okay, so now we have some examples of simplifying these things. So you need to pay attention to what the variables are. I'm going to rewrite this, just putting the x's beside each other and the y's beside each other. X to the second times x to the fifth, and then we have y to the second times y to the third, because these bases need to be the same in order to add the exponents. It means there are 7 factors that are x, and for y we add the 2 and 3 and we get 5. So that is simplified. X to the 7th, y to the 5th. Okay, I think I'll go over here so I have a little more space. Again, putting the same bases together first. I have x to the second. Here's another x. X to the third. Y to the third. And out here's another y. And then that's the only m. M to the fifth. Okay, so again, add the exponents for the x's. 3, 4, 5. Add the exponents for the y's. Also a 5. Well, these are all 5s. Okay, that's it. Okay, so here we have x, understood to be x to the first. I think I'll write that, so don't forget to add 1 to the other one. Here's x to the third, and then y to the first, y to the second. Add these, add the exponents for y, and there it is. And then down here, make sure I'll be able to see that first. Okay, so on the fourth example, we have, there's m to the third, and then here's an m, that's m to the first. Here's an m squared, and that's all the m's. Go back through here, I have a p right there to the first, and out here's p to the fifth. Okay, we got all of our m's and our p's. Here's an x, x to the first, And here's another x, x to the third. And then we add our exponents. I got all the different variables. Okay, so for m, that's 6 when we add those three. P, that's also 6, 5 plus 1. And then x, 4. M to the 6th power, P to the 6th power, x to the 4th. And that's all we have for part A. Okay, for part B, we're still dealing with exponents, but now we're just comparing them when we're looking for like terms. Because remember, like terms have all the same variables, but those variables also must have all the same exponents. So I still like the table idea for these. Also, whenever let me just do that for this one. So we have, and just to make it easier to compare, I'm going to alphabetize these factors. So I have p to the 5th, x squared y. You don't have to do that, but if they're always in the same order, it's just easier to compare. So alphabetical is a nice way to do that. Okay, so p to the 5th, x squared y. Okay, here's p to the 5th, x y squared. That is not the same. X is to the 1st, here it's to the 2nd. Okay, so p to the 5th, x, y to the 2nd. Remember, that variable just goes to what's right in front of it. It only is on that y. That is x to the 1st right there, just like this was y to the 1st over here. Okay, next term, we have a p to the 5th. That's the same as both of these. X squared, that matches this one. Y, that'll match this. I could have been putting my numbers in. For x squared, y, p to the 5th. Okay, this was an understood 1 coefficient, so 1. And then this was the second one, that's a 2. Now, this one, I said matched the first one here. We had p to the 5th, x squared y. Alright, so that's a positive 3, goes here. Now, in the last term, I have p to the 5th, x, y squared. It does totally match this. That's negative 7. That's all 4 terms. So now when I add these, this 3 plus 1, they're both positive. That's 4. P to the 5th, x squared y. These are opposite signs, so I subtract. The larger is negative. So we're going to have a negative 5. So I'm just writing minus 5. It could be plus negative 5 times p to the 5th, x, y squared. And that's it. On example 6, same kind of thing. Let's see. So, and again, I showed you with the other time we were adding like terms, you could like underline these and put squiggles under the other ones if they're not like each other. But I really think the table is a very nice way of organizing these. So I'm just going to keep doing that. We have m to the 3rd, p, x, y squared. And again, I'm only alphabetizing these factors just because it's going to be easier for me to make sure I find them when I'm comparing the other terms. M to the 3rd, p, x, y squared. Okay. And that's a 2. Okay, m to the 3rd matches, p matches, x matches, this one matches. Okay, so 3. Now on the next one, okay, m to the 3rd, yeah, okay, p, x, y squared. Okay, also matches. Maybe they're all like terms. Okay, m to the 3rd, p, x squared. Okay, that doesn't match. So, just that one extra term m to the third p x squared y. Okay, and that is an understood 1 for the coefficient. 1, 2, 3, 4 terms in here. 1, 2, 3, 4 numbers here. I know I got them all. So now I can add this column. These two are both positive. That gives me 5. And a negative 10 gives me a negative 5 of these. M to the third pxy squared. And then we have one of them. M to the third px squared y. That is all we can do with that. And then one other example. They're all very similar to each other. Okay, this one actually is kind of nice because it has fewer variables in each of these terms. So we have, maybe I'll just try the underlining thing for this one. This is x squared y. Here's an x squared y. Okay, x squared y, x squared y, x squared y squared. That's different. X squared y, it's like the first two. X squared y squared, that's like this one. Okay, so now the ones I just underlined, I have 2 plus 3 is 5, minus 1 is 4. So 4 x squared y. And then for the squiggly ones, we have a 1 minus 4, so that's negative 3. I can just write minus 3 x squared y squared. And that's that. End of lesson 21 notes.